Hey everyone, and welcome back to another YouTube video on Arena Simulation. Today I want to talk through the Arena Airport Security Example 2. After watching this video, you should be able to answer the textbook questions for this problem, as well as use modules such as the record, variables, and a few of the other more basic modules that you've likely already seen up to this point. Let's go ahead and get started. So just jumping into it, as a quick reminder, we are starting from the Airport Security Example 1 base solution. If you didn't see this, I do have a previous video that does go over this one. By the way, you can subscribe on YouTube to see more arena simulation and other industrial engineering videos as they come out. Now let's go ahead and take a quick look at what this simulation looks like. As you can see, we do have customers coming in here. I'll go ahead and slow this down. Passengers arriving to security. They go through a seize delay release example where the TSA officer is checking for proper identification, and as a result there can be a queue that builds up. You have the queue graphed at the bottom there so you can actually see what's going on. And then if they pass security, they're sent to an X-ray baggage check machine, which is not animated, but it does exist, and I think there are two of them. If you don't pass security, you don't go through the X-ray baggage machine. Now there are, and of course we finish with a dispose module. Now there are a few questions that the book has for you, and they're actually pretty good ones, that can help you think about problems like this one. So taking a look at the example 2 here, which is on pages 24 and 25, you're going to you want the simulation to enhance the random security check for all passengers by adding more extensive security. And what this is going to do is where the 15th passenger is going to have a full body scan and manual review. So the first person won't have it, the second person won't have it, the 15th, 30th, 45th, etc. will. It's not entirely random, it is a fixed number, so it's not entirely secure, but it is something that's interesting and new for you to model. The inspection here usually takes 5 minutes, so that's going to be something we want to pay attention to. At the minimum, it's going to take 3 minutes, and at the most 10 minutes, so that's telling you you're going to have a triangular distribution with a 3, 5, 10 parameters. And of course, there are unlimited resources to model this process, so you don't need to add in a second TSA officer, you don't need to add in a machine, etc. In fact, you don't even need to have a resource to be seized. This can be a simple delay module. Now the question that you are wanting to answer is, what is the overall average cycle time from entering the system to leaving the system of these specific passengers who are selected for the check? What is that time from start to end for all passengers? And there's a few hints that we're going to get into. Now what I want to do is initially take a look at the system here, and we can go ahead and stop the run. And I want you to think about, where are we going to add in this extra random security check? And of course the answer is in the question here. The question is after the baggage scan. So random security check is necessary after the baggage scan, which means that we're going to do a little bit of modifications here, and we're going to add in some sort of random security check after the baggage scan. Of course, you wouldn't need to, you're doing this after the baggage scan because there'll be fewer people who are going to go through that process and are going to be denied by security. You don't have it ahead of that, otherwise you'd have more people going through this process. However, after the baggage scan, you could argue maybe it doesn't make too much sense because the passengers wouldn't have to wait through and the X-ray machines would not be seized, but that's what the question says, that's what we're going to do. So we're going to have some sort of delay process, is what I already said it was. This could just be a pretty basic process module that was just a delay. I'm just going to call it a delay module, and I'm going to call it additional security check. Now this delay time is going to be, well, let's see, allocation. Looks like I can't do a standard delay module. I need to do a process module, so it has seize delay release in there. So we're going to call this the security check, and it's going to be a triangular distribution we already talked about there, with a minimum of 3, max or most likely value of 10, and most likely value of 5, and a maximum value of 10. We could call this non-value added. Wait, it doesn't really matter for the purposes of this question. And of course we want it to be in minutes, and let's check that we got the 3, 5, 10 correctly and see what the next thing we want to add is. So yes, it takes 3, 5, 10 minutes, and there's an unlimited availability of resources, so we don't need to seize something. If you want to know how to seize something, you've already done it in extension 1 and the base model here. And now the interesting thing is we want to we can go ahead and start reading the hints of how are we going to record the overall average cycle time of the passengers. Well, that tells us we want to be using the assign module and a variable to keep track of the number of passengers through the process. I guess that question here, this first one, is how do you make sure every 15th person is seized? So what we could do is we want to add a variable and add 1 to that every time a passenger comes through. When it's 15, we want to send them to this extra process and then reset that. Let's go ahead and sketch out what this might look like here on some of this. I'll go ahead and delete the description. We probably don't need that anymore. So after they go through, there's going to be a security check, but of course not everyone is going to make it to that one. Only 1 out of every 15 are. So I'm going to call this selected for additional. It's going to be a two-way by condition, and we're going to get into what the condition is going to be here in just a second here. And it's going to be a variable, but we'll get to setting that up here. And of course, if they are selected for additional screening, we're going to move them to the security check. If they're not, we're going to move them to a separate dispose module because we don't want to use the same one here. So we're going to say have an extra dispose right here. We can call it dispose 3. It doesn't really matter. Now that we have our dispose module set up, we can think about how we want to handle screening every 15th passenger. And as the hint tells you, you're going to want to use an assign module and a variable. What we want to do is have an assign module where we give someone a counter, and then every time another person goes through that, we take that counter and increase it or increment it by 1. And then after someone goes through and is selected, we're going to reset that counter. But let's see if we can do that first part all the way through. So this assign, we're going to call it assign counter. And what I want to do here is add an assignment and have a variable. And I want to call this variable vCounter. Now, this is just going to assign it to 1 the first time someone comes through. By default, it's going to be 0. But what we want to do is have it equal to itself plus 1. If you've taken traditional coding classes, this is x equals x plus 1, for instance. So we're going to say that the new variable is vCounter plus 1. So that's pretty good. Let's see if we can check and troubleshoot or debug and see if that's going to work. So for that to work, let's connect it. And I'm not really worried about resetting it yet. But I also do want to go through and make sure the decide module is set up correctly here. And I've already done this, and you can see that I've said that if vCounter is exactly equal to, and that's the 2 equal sign, is equal to 15, we're going to send someone through dispose 3 through the extra processing here. So let's go ahead and run this, but in order to do that, I actually do want to animate a variable on here. So let's just see if we can animate the variable here. Let's see, current value of vCounter. That's all we want to do here. We can even take the format and we can change it to a few decimal points or whatever if we want to. So this is going to be vCounter, and that should just work right here if I just add that variable box right here. That's the counter of what this is going to be. Now there's no reset module in here yet, so what we should see is the first person is going to go through and then they're going to have the counters increased. The second person will go up to 2, 3, and then this is just going to keep going up to infinity. So that works pretty well, and we actually did see there, if you slowed it down really, really slowly, one person did go through the selected for additional when it was equal to 15. So it looks like our logic there is working correctly. But what we want to do now is add a different assign right here for once the first person, or once any person really is selected for additional screening, we're going to add an assign reset. What we want to do is we want to reset the variable vCounter to be equal to 0. That way it will work and every 15th person will go through. Let's go ahead and see if we can connect those, which looks like we can totally fine. So what we should see now is that when we run this, and let's go ahead and speed it up till we get to 15 or so, 4, 5, 6, 7, we should see that person number 15 goes through and a reset back down to 0 and was selected for an additional 1. And if you want to, you can play around and reset it to 1 instead of 15 in every 14th person, except the first one is 15, but that's not really what the question's asking. So it looks like we have that selected correctly. When by the time this gets up to 45 through dispose 3, we should see one more person go up there, so it looks like that worked out pretty well. Nice. I guess it counts these two combined. So when those two combine, we're 45. So now let's think about the second part of the question, which is where it's asking us to get the cycle time of the passengers who are selected for screening. And again, it asks for cycle time as the difference between the time where this person starts, so when they enter the system, to the time where they exit the system. And this is likely going to involve a new module, the record module. So let's go ahead and take a look and see what kind of thing and where we need to add this. So what we want to do is at the very start, when they enter the system, because again, there's no actual simulation time between passengers arriving and the entity traveling down this line, we want to add something right here to add a new attribute to these entities that come in. We want to add something at the very end to record that, or get the differences between the start time and when they reach the end. So this is going to be assigning an attribute as opposed to assigning a variable. Let's go ahead and connect this and make sure it works. Now what I want to do here is I want to have a new attribute, and let's call it to the active entity, the entity that shows up at that particular time to this module. And I want to call the attribute, I'll call it start_time. And I'm going to have the value be equal to tnow, which is arena syntax for the current simulation time. So if I go ahead and do this, I should be able to pause on a particular entity, at least, unconnected exit point, that makes sense. I should be able to pause on a particular entity and see some of these statistics. So both of these people here are in line. If I click on that, I should be able to see that it has an attribute of, well, let's see, user defined. Oh, let's open that up, a start time. So this person came in at 5.5 base units, which is likely in minutes. If we click on entity number 2 or entity number 6 right behind them, we should see that they have a slightly higher user-defined attribute here, which again is start time. I guess that's lower. I could have got that switched around. Entity number 6 is still in line. Regardless, that's what it looks like. We have attributes that are being assigned to these particular entities. We have the attribute, but when they reach the very end, we want to get the difference between what was their start time, because again, that is recorded, or that lives with the entity. We want to record the difference between the start time and the then current time of the simulation. And this is where we're going to use a new module, which is going to be the record module right here. So let's go ahead and stop the simulation so we can add in a record module, which is again under the input-output group. Now this record module, we want to connect that there, and it's after the security check because that security check is basically a delay process. Let's call this record. We can just call it record, doesn't really matter. There should only be one of these. And what I want to do here is I want to look at the time between value, the time interval. And what I want to do is look at the time between the start time attribute, and I want to record, that, and this is the time interval from the start to the then current time. And we can record that, it's a tally statistic, so we can record that as whatever name we want to do. And let's see if we can't say this is going to be, I'll say average, I'll say it's the cycle time. It's just the cycle time for this person. And there's going to be a cycle time for the first person that is delayed by this, the second person delayed by this, the third person delayed by this, etc. So all we're going to do is have a bunch of different cycle time variables across each individual entity. And again, that's why it's a tally statistic right here, tally variable. That record module is there, but now we need a way to see the record module, when maybe we can do that while it's running by going through and adding in an animation. Let's do a variable right here. And the expression I want to animate is, let's go ahead and do build expression. I want to take the t average of, and let's see what I call that, of the cycle time right there. And that is the syntax for what we want to do, the average for time for tally for this right here. So if we do that and have the format set to whatever we want to, this should actually work out, and it might start to be 0, but let's actually see what we can see with that one. T average of the cycle time. Now let's go ahead and run this and see if anything breaks. Looks like nothing is broken so far, and this value right here is still 0 until the 15th person comes through, which we should see. 15th person came through and that didn't update, so that's cool. Ah, it did. They went through the, when they went through the record module right here, we can see that the average time was 12 minutes. And what we should see is that we can run this until a second person is selected for additional screening, which should happen when the counter on the left reaches 15. So let's just do a few steps. one more. Come on, come out of here. So 15, they did the 15th person came through, and that person went through the assign, resetting the assign counter. Then we had the security check, and then we had the record module right here, and that was reset to be equal to 10 minutes. So that second person should have had a time of 8 minutes. The first person had a time of 12, averages to 10. And we can keep writing this up until this reaches, we have a third person come through, which again happens when our variable counter resets. Right now they're in the security check, so we can actually see if there's an entity, if we can see what entity is in there. Looks like we probably can't. But I can run some steps, and by the time this person exits the security check, which again takes some time, some simulation time, we should see that now this example has gone up to 12. If you wanted to, you could look at a graph over time or something of this, or graph for each individual entity, but I don't want to, so I'm just going to keep this running to infinity so we can try and answer the question, which again, in our textbook here, the question is, what is the overall average cycle time of passengers? And this should let me answer that because I'm looking at the average cycle time of passengers who are selected for this check, again using T average under Arena. So taking a look back at Arena, what we can do is we can just fast forward this or increase the speed dramatically. And as you can see, it's pretty close to 15, 16. You could compute a theoretical average for this person by taking the average for the proper identification check, which is 1.5 minutes, taking in the baggage x-ray, which is 2.5, so now we're at 4, and then taking in the security check, which is 5, so that's equal to 9, and then you could do some math to figure out the average expected wait time for each of these people. As we should see here, it's going to approach some sort of standard value. If I skip all the way and fast forward through the simulation, we could even see what that turns into at the very end. So doing that, and it's going down through the run here for the number of minutes I've asked it to, you can see it running at the bottom, we could get an answer without the animations of what the overall average cycle time is. And yeah, let's go ahead and look at the results, why not? It looks like that's 19 minutes, and if I open up the results in Notepad, you can see that it's kind of difficult to figure out some of these things. So if we go down and look at the tally variables right here, I don't know if we actually have the cycle time variable in here at all, which is again why we're using the record value at the bottom here. Maybe it's in here. I could poke around and find it a little more if we could, but if you added up some of these values, you should get that same 19. You could even have it, you could even give it more decimal points and stuff like that. So there is your Arena example 2, and we can actually go ahead and check against the solution of how I did versus how the solution key looks like. And again, we'll run through this in step by step so you can actually see what goes on here. I guess I should stop running the first model to run the second one. And let's make sure our run setup here, well, we can just run this one. Looks like things are going pretty similar to mine, except they have some nice text spelling out what the counter variable is. As you can see, they have a very similar thing here. They have the assign time coming in as you start, so they're assigning it as T now, which is fantastic. After they go through the check, x-ray check, we are assigning the counter here equals counter plus 1. They have the extra screening. If the counter is equal to 15, it will send them there. And then if they do go through, it will reset them. So variable is now, the counter is now 0. It goes through this additional check, which is a 3, 5, 10 triangular distribution, has a cycle time for the selected passengers, where it's the time interval between a underscore time in, so attribute for the entity, and they're calling the tally statistic name the cycle time for the selected passengers, which means that their extra passenger screening average cycle time is going to be T average of cycle time for selected passengers. And that is just the same one that I've got. If you are interested in these solutions, you can click on File, Browse Examples, and that will get a ton of other examples. So what we should see if we run this all the way to the end, it should be 19 or very close to 19. If you did enough replications, you would get approaching the same average number that I did. So you can see that these are the same. So I hope this video did help. If you have questions about arena simulation or other industrial engineering topics you'd like to see me cover, go ahead and leave a comment in the section down below, and I'll be able to answer that. And as you can see, we got the same variables, likely because we're using the same random numbers. I hope you were able to learn something useful about industrial engineering, and I'll see you next time.